All right, I just want to do kind of I guess a follow-up video on the project for the dump load, the vert load for the wind turbine. You can see right now we're actually indicated by the auxiliary 2 indicator that keeps lighting up there on the screen. We are actually diverting right now. So if I go up and we look at the unit itself, to zoom in here on the screen, you can see that the duty cycle is it's varying, and it's basically sending that portion of the power coming from the turbine through the resistors. Now there's 8 resistors, 300-watt resistors in there. And we can see that there is a current going through. You can see the bottom reading in blue is the current, and the top reading in red is the voltage that the resistors are seeing. And just sort of give you an idea of how this thing actually works. So I did go ahead and incorporate the test function. By pressing the button here, you can get to the test function, and you can reset by pressing it once. You can reset the temperature, the high temperature. If you press and hold, you can run the test. Now the test can't be run while there's power going through it because it actually checks for open circuit on the resistor bank in there, and it has to measure resistance, and can't do that while there's current flowing through it. So there is a warning on this. When you press the button and hold it, it will warn you not to do it while the turbine is turning. But normally it would run through all the functions of the unit, turn on this display and run false data through, and run up the temperatures and the duty cycle all the way up to 100. And then it would run the test on the continuity of the resistor bank to make sure that everything's good there. So the full test is now implemented just by holding that button down. And the reset of the high temp is just a quick press and release on the button. You can see the light is working, that indicating that we are in the on state and we are in divert. If the divert level goes to 0, that on will go away and you'll see the light go off. And if it went to 100% divert, then the light would actually start to flash. The USB port is also active and working, and I can update the software just from the front of the unit. It makes it convenient without having to pull power from it to update it and then plug back into power afterwards. It makes it much more convenient having the port on the front. So bottom line here is this thing's purpose is basically just to absorb any energy that the wind turbine's creating that is not needed by the system at that time. And I decided to get a lot more elaborate than just a bank of resistors. So that's why we ended up with an Arduino in there and a bunch of other circuitry measuring the duty cycle, and measuring the temperature and keeping track of the high temperature, and with the current and voltage meter. And then I ran the test function code in there as well, so that it would be capable of running tests on all of its functions, including the continuity on the resistor bank. And it kind of ballooned out into this much larger project. So I'll put up a card for the whole playlist for the dump load. Dump load's been complete now for months, maybe a year at this point. I'll have to go back and look. But it works quite well. And it's much better than the kind of thrown together bank resistors I had before. And it has that sort of advanced function that I decided I wanted to have in there to tell me exactly what was going on with the power. Because once you see that you're in divert, when that auxiliary 2 is lit there, you really don't know what the turbine is actually making for power, how much power you're just dumping. So I decided I wanted to know. So now I do, and made for an interesting project. Used a lot of the tools in my shop, including the 3D printer, of course, the whole electronics bench with the Arduino circuitry and all the other circuitry that went into this, as well as a bunch of machining that had to happen, getting that opening for the screen and making the mount for the resistors and all that stuff. So uh, anyway, just thought I'd do a follow up just to kind of show it working and that it's actually gone quite well with actually no problems at all. It works really well. Anytime that I see that there's no wind and I think I'm thinking of it, I'll hit that button and hold it in. And the only thing I might change on the code now is that I might make the test run a little quicker because it takes a long time to hold that button down and let it run through all its stuff. So I might make that quicker. But you can see I've got the uh, the screen looking a little bit better. I had to switch it out from the blue screen to the green screen just because of the fit. The screen's a little bit different. So the 3D part that I printed out to mount the screen only fit the green one. But you can see I've got the little Fahrenheit indicators in there and degree markers and high temperature. So it actually looks pretty good. I might decide to 3D print a new mount and get the blue one back in there because I think that one looks better. But the only other thing, just make that test run faster, and I think we're done. But I might just leave it as is because the test is, you don't run it that often, but it would be cool if it was a little quicker.